Hi, in this video I'm going to talk about the path I took to get really good with Git. For me it was fairly straightforward to get going with Git. I just learned a few of the basic commands and started using the system this way: add, commit, push, pull, check out if I needed to work with branches. This really helped me to use the system, but I wasn't understanding the system. That was really a different thing. I ran into a lot of problems. The system got stuck. I didn't know what was going on. I needed to search on the internet, end up on some Stack Overflow page, hoping when pasting some commands into my terminal that it would fix my problem. But I wasn't really improving my understanding of the underlying system. I was merely working around my lack of knowledge by copy-pasting from Stack Overflow and hoping for the best. Next to the learning path that I'll lay out in this video, there's two key points that I want to highlight. One is learn Git on the terminal, really stick to the terminal. And the second one is to learn the internals of Git. Git may seem like this complex beast, but it is built of small, elegant and fairly simple building blocks. Once you get familiar with them, life will be a lot easier. You'll get to grasp the whole system a lot easier because you know what it's made of. I'll have an example in this video. So why the terminal? I have 7 which I think are very compelling reasons to stick to the terminal, and I have 2 exceptions for which I think visual tools do a better job. First, because it's faster for most tasks, because using a keyboard with shortcuts is just faster than using a mouse, and UIs are sometimes implemented badly. It also means you can automate things when you're ready. For example, in bash aliases, you can combine 2 commands, customize it in your own way. UIs allow for some form of automation, but it's definitely not the same. Next, it creates a better understanding of what actually happens under the hood. Git is famous for its really clear status and error messages. Tools often hide these things. This is how you get to mastery, by reading all the messages, performing all the small tasks manually again and again. This is how you improve. Thirdly, it has all the Git commands. UIs often implement only a subset of what Git can actually do. If you know the terminal, the UI is easy, and this is not true the other way around. You can use most resources on the internet. All the documentation will work for you. If you've learned only a specific UI, then only that documentation will be able to help you. If you find a solution for your problem on Stack Overflow, the answer is often paste these in your terminal. You want to know what's actually happening there. Whenever you're assisting somebody, all users will have a terminal with Git. Git is complex. It will break for you at some point, and fixing it usually requires the terminal. You might as well get to know it right now. The 2 exceptions. I think a 3-way merge tool is really something that you need to look visually. In your editor, Visual Studio Code, for example, does a really good job nowadays. You have the situation in a branch that you're merging to, you have your changes on the other hand, and you have what Git suggests is the best way to merge this. If there's conflicts, you need to fix them manually. This is what is proposed. You can see the old and the new. You can work on the better solution there. The other exception is adding files to your index or staging area where they're ready to commit. This is simply more natural in a editor where you can look at the contents of a file so that you can more easily decide, I want to add this file, but I do not want to add this file because I don't want to commit it. Next, I have a suggested learning path for you. First, the basics with already some internals so that you can quickly become self-sufficient. Then, how to write great commits and make great pull requests, merge requests. Lastly, branching strategies. Branching strategies are really key when you're working together. They can either support your workflow or they can be in your way. They can be a blocker in your process. So it's key to pick the right one there. First, the basics. So Git can become a useful tool as quick as possible for you. I've got 2 recommendations here. The Pro Git book, read chapters 1 to 3. It's freely available online. I'll show it in a second. And the second one is the Learn Git Branching website. I'll show it as well. If you go to the official Git website, under documentation, you can find the book. The entire book is available as a webpage. I would highly recommend you read chapters 1 till 3. Getting started, Git basics and Git branching. It will talk about committing, undoing, looking at history, It will talk about branching, merging, even rebasing, and especially it will talk about the internals of things, so you really get to know what happens under the hood. The next thing that I highly recommend to run through is learngitbranching.js.org. It's a website, it's a game actually that works like a terminal, and at the same time it's visualizing how it works. It's visualizing the history, it's visualizing your commands, it's giving you assignments, you get to play each level and you get to see what happens. So this is a great way to actually get better at Git. I love this website. I think it's a great way to learn. It has many levels. Also on the remote tab there's even more. I challenge you to finish them all. It will greatly improve your understanding and you'll have a lot of fun along the way. Next, I think it's important to learn how to make small atomic commits. These are commits that only contain changes that are related to each other, that are described by a single message. There should be no changes in there that are not described by that message. They should all be a single responsibility. Atomic commits can be easily reverted because they shouldn't change something else and somewhere else in the system. They should be related to each other. Another best practice I really like is the use of the imperative mood in commit messages. This could be the use of the word fix and refactor instead of fixed, refactored, or fixes. I'll link to an article in the description with this and many other best practices. One last tip on commit messages is the use of the conventional commits standard. Conventional commits is a specification for making commit messages human and machine readable. This can be useful if in the future you want to parse your commit messages log so that you have that you can generate a change log from it, for example. There's a type, optional scope, and a description. Then there's a body and a footer. These are optional. Some examples here: feat from feature, an exclamation mark if it's a breaking change, optional scoping, useful stuff. Next, learn how to make great merge requests. Ask yourself and your peers, what does it actually take to want to review merge requests? How can we make it easier for ourselves and for others? Should we do descriptions or titles in a certain way? If a front-end developer might, for example, have implemented a complex interaction in the UI, might he attach a video so that it's more easy for us to see how we should actually test and review this code so that we understand what's going on there? There can be many ways of doing this. Lots of it is specific for teams. Focus on it. Take some time. Another way to make life easier for your reviewer is to first explain your solution direction face-to-face or on a video call before you hit them with your pull requests out of the blue. I actually talk about this in one of my previous videos on code reviews. Next, it's important to learn about branching strategies. These are a set of rules or conventions that help you guide your process. When should you merge which branch to which branch? Do you have release branches? What happens if you have a problem on production? Do you have an always stable main branch? When do you make a new feature branch? There are two obvious ones: Git flow and trunk-based development. Git flow is over 10 years old and it's from a time when continuous delivery wasn't the standard yet. And it's still good to learn about it. There's many things that we still use. I mean, feature branches are still there, and this was the initial model where this was conceived. Release branches and hotfix branches, these things are not common anymore because having a release branch long-lived, which spans a certain testing phase before you dared to release to production, that's not really anymore what we think of when we're working with a model like continuous delivery nowadays. Trunk-based development is a system where we have an always stable main branch and we make feature branches of that, but we make sure we integrate at least once a day, again, so as soon as possible, as much as possible, so that we have this always stable main branch we can always release from, and testing doesn't take as long. And lastly, I want to talk about internals. Specifically, I've implemented 3 fundamental objects as super naive JavaScript objects so that it's more easy to relate to: the blob, the tree, and the commit. Let's take a look. In here, I've got a list of blobs. By the way, all of this is stored on disk. You can simply inspect it with simple git commands or just listing the .git directory for every repository that you have cloned. Anyway, a list of blobs, a list of trees, and a list of commits. So these are objects because they're all identified by a unique key. There can be no duplicates. Trees as well. And in this I have single commit, right? The blobs are identified by a hash. A blob is really only the file contents, which is the only thing that is on disk. If you have a source code, there's no metadata attached to it. A tree is a list of references. So this is a list of references to other blobs and other trees. So this tree has a reference to another tree, namely the other tree. It also has a reference to a blob. And commits reference trees and have metadata. So in here you can already see there's a directory structure, because this second tree refers to this tree, the first tree, and names it the source directory. So if we inspect this tree, then it has another tree as a reference and it has a file. So the readme.md, the markdown file, is in the root directory. Then there is a source directory referenced to by this. In the source directory is two files. Logo PNG is the name of the blob with this content, which is this binary file, and main.js is the blob with this content, which is this JavaScript file. So this commit is referring to a tree, and it has a message, it has an author, and it has a date time. If there will be other commits in here, they will get a parent. This is a root commit. And that's it. Now you have already a grasp of the basics of these blob trees and commits. References are just pointers, named references to a specific commit. So any branch and the head, which is the keyword for what you have checked out, is also just a simple reference to a commit hash. Let me show you what happens if we add a commit to this. So I've split the window, but we're looking at the same thing here. I've added a commit to it. It's a commit on a later date, and it now has a parent that is not null. This parent is referring to the initial commit that we already had. It's referring to a different tree. The tree is 76, which is the last tree that we've added. It has the same reference to the source directory and all its contents, because it's literally referring to that same blob, but it is referring to a different readme blob. It is still named readme, but it has a different ID. That's because we updated this hash. And here you can already see one of the advantages of Git, because we are only referring to a newly updated readme, but we are still referring in this commit to the same old source directory. That hash hasn't changed. This means that any blob in here, nothing is copied on disk. The only thing that when we added this one commit, the only thing that was added in the blobs is this file. So it added the new file that we have changed. We can still access the old file, which is why Git can go back into the history, but we now have a new version of that. And we have these example refs. So we have a head, which is the last commit, which is the one. Head is basically a way of saying this is what I have checked out right now. We have a main branch and we have a feature branch, which it's a silly example, but it now refers to another commit, which is the initial commit, because maybe I made this feature branch and maybe I forgot to delete it. So the only thing refs are is a reference to a commit hash. The same is for branches and tags. It's just a ref. And that's it. I hope this was helpful. I'd like to hear from you. Are you currently learning Git? How's your experience? What are you struggling with? Did I miss anything in my video? Let me know in the comments. Thank you very much for watching.